Hey guys, welcome back to the channel. Today we're going to be solving Leetcode 152 maximum product subarray. This is a continuation of our previous video where we started solving this problem, but we solved it in a brute force method, and as a result we got a timeout because we got a timeout whenever one of our test cases was an array that's this big, so we timed out. This is a correct solution, by the way, but now we're going to solve it in a more optimized way. And the trick for this more optimized solution is to realize that we have to keep track of our negatives. Okay, so just like we have this array like in the example 2, 3, -2 and 4. Okay, so just let's add one more negative. Let's say -1. Okay, in this case, say we want to just multiply all these elements in this array and get the maximum multiplication. Okay, the maximum multiplication in this case would be, okay, it will be 2 and 3, again contiguous, right, which is 6, right, because this guy makes it negative. Once you get to this guy, anything that has this guy in him would be negative. But however, if we added, this is our maximum, but our minimum, if we had this guy in there, so our maximum is 6, our minimum contiguous is going to be everything multiplied by each other. So our minimum is going to be 6 times -2, which is -12 times 4. So 6 times 4 is 24, 24 times 2 is 48. So our minimum is -48. However, if we added this last guy into the array, this -1, if he was part of the array, okay, in this case, our contiguous array is just going to be the whole thing, okay, 2, 3, -2, 4, -1. And guess what, our maximum at this point is now 48, okay, because we added the second -1. And what is our minimum? Our minimum is actually, if we just took maybe -2, because it has to be contiguous. Okay, so now our minimum and maximum has changed, all because we kept track of this negative guy. That is the trick, keep track of the minimum and the maximum. So let's go ahead and code it and see what. So again, I'm gonna create a new function which I'm gonna call I'm gonna call max product 2. For now I'm gonna say pass. Okay, just for now I pass for. Okay, and I'm also gonna call him, okay, max product 2. Okay, let's just run it and just make sure it kind of works. Oh, okay, 2, we didn't call him 2. Okay, let's run it and make sure it kind of works. Okay, good, return none, it works. Okay, so what did I say? Okay, just like before, we want to initialize our max product to an element as low as we possibly can. So we're gonna make it -infinity. Okay, it's too straightforward. Now we're gonna have to create 2 variables. Our current, I'm gonna call it current max, okay, and our current min. Okay, and what do I want to set it to? I'll just set it to 1 for now. As long as you set it to a low number, it's fine. Okay, so now I want to iterate through the array. So I'm going to say for num in nums. Okay, iterating through nums just like before. Okay, what do I want to do? I want to create a value just to keep track of my previous maximum value. So I'm just going to call him old max. Again, hang with me in here, it's gonna make sense in a little bit. An old max is just gonna be current max, our current max multiplied by the current number we're on. That's all, because we want to keep track of the running product. Okay, or multiply by the current number we're on. Okay, let's just print him just to see what he is real quick. Okay, let's just print him just to visualize it a little bit. Okay, bam. Okay, just at this point 2 and 6, right? Okay, so that's 6, right? Then next, okay, it's just our running product, right? If you keep multiplying the current guy. Okay, so let's go ahead and take him out of here because we don't need him. We don't need to print it. Okay, so I'm gonna calculate my current max. Current max is just gonna be the maximum. Okay, we want it to be contiguous because we're looking for a contiguous running array, right? Okay, so he's just gonna be whoever is the biggest between my old max, okay, and keep in mind that I said we're gonna have to keep track of this minimum guy. We always have to keep track of him regardless. Okay, whoever is the biggest between our old guy, the current minimum multiplied by num. So keep in mind that all we're doing here is just we're comparing current maximum multiplied by num, which is old max, just the same as copying and pasting right here, versus current minimum multiplied by num. Okay, whoever is bigger, okay, and just num. Okay, whoever is bigger of these 3 becomes our current max. Okay, it's also similar for our current min. Okay, similar for our current min. So our current min in this case, min, is just gonna be in this case minimum, not maximum. Whereas the minimum, because like I said earlier, we're gonna have to keep track of our minimum value. Whereas our minimum between our old max, current min, multiplied by num, okay, and num himself. Okay, so once you do this, now let's find our max product. So our max product is just gonna be the maximum between himself and our current max. You can add current min in here, but he doesn't add any value because every time current min becomes positive, he gets saved into current max, just like we explained with the negative 48 and 48 here. Okay, so after we're done looping, we want to return. Guess what we want to return? Yep, you guessed it, max product. And again, just so we can visualize, I want to print all three of these guys. Okay, I want to print current max, current min, and our running max product, just so we can visualize. Okay, so let's see. Okay, let's ignore this guy for now. Okay, so at 2, current max is 2, current min is 2, max product is 2, obviously, because it's the max. Okay, now when we go to the next one at 3, current max is 6, current min is 3, okay, because he's smaller, and max product is 6. At negative 2, okay, because we're here now, negative 2, current max is negative 2, current min is negative 12, right, because negative 2 times 6, okay, and this, at this, okay, at 4, current max is 4, current min is 48, and current max is this. So let's add a negative 1 like we did in our example. Okay, and see, bam, 48. You see, that's why it helps to keep track of the min. So let's go ahead and take this into Leetcode and see what they have to say over there. Okay, so I'm just gonna go ahead and delete this guy. Then I'm gonna paste this guy in here again, like always, take him back all the way, take him forward. Okay, then indent our 4 guys. Okay, we don't need this print statement, so I'll just take it out and I'll run this code. Accepted. Let's go ahead and submit it. Bam. Okay, this works, however it's terrible, 5% faster, but space is doing good. Okay, as always, let's go ahead and take this code one step further. Let's go ahead and step through this code just to see what's actually going on. Okay, as always, let's take out this guy because we don't care about, we care about max product 2. Okay, let's visualize him. Okay, I'm just gonna step through this real quick. Okay, bam, bam, bam. Okay, good. We've defined our function. We're in the scope of the function. We've defined everything in global scope. We've defined our norms. Okay, pointing to the same array list in memory. Okay, so now that we have this, our max product is gonna be infinity. Okay, boom, just like we said. Our current product and our current max and current min is gonna be 1. So now our for loop. Okay, like we said, our old max is just going to be current max, in this case 1 multiplied by nums. Num is 2, which is the first element, so he's going to be 2. Now our current max, whoever is maximum between old max, which is 2, current min is 1, and num is 2, so he's just going to be 2. Current max is going to change to 2. Okay, current min is whoever is minimum between those guys, so he's going to stay 1. Oh, I'm sorry, they're all 2, so he's going to change to 2. Yeah, so again, we don't care about the print statement, so we're just gonna keep iterating through it. Again, just like we explained, it's just gonna keep doing the same thing. Okay, just keeping track, just by the fact that we're keeping track of everything. And then let's go back one more step. He returns 6 in the end. Why? Because 6 is what we want. So that's it for the video, guys. I hope it was helpful. I'll see you on the next one.